Okay, now we're going to graph log functions without the use of our calculator. So we're going to start with log base 2 of x. You can think of this in terms of plugging in points and thinking in terms of our exponential notation. So for example, if you plug in x is equal to 1, you're thinking 2 to the what power is equal to 1. That would be 0. So when you plugged in 1 for the x, you got 0 for the y. This is going to be true for every single log function. No matter what base, you're always going to have the point 1, 0 on the graph. If you plug in an x value that matches the base, 2 to the what power is 2, your answer will always equal 1. No matter what the base is, if it matches, then you're always going to have the y value of 1. So base 1 is another point on every log graph. In this case, it's 2, 1. If you want to put in a couple more points, that's fine, like log base 2 of 4 is equal to 2. So 2 to the second is 4. If you want to go backwards, you want to think like 2 to the negative first power is 1/2. So if you graph those last 2 points, when x is 4, y is 2. And when x is 1/2, y is negative 1. And we already know that the log function is an inverse of the exponential. The exponential ran along the x-axis. The log function is going to run along the y-axis. So there is an asymptote at x equals 0. So it runs along the y-axis and continues to go through those 4 points that we plotted. Looking at the next one, it's the same idea, but the base is now between 0 and 1. So our base of 1/3. Again, if you plug in the number 1, anything to the 0 power is equal to 1. 1 0 is on every log function graph. If you match the base, you do log base 1/3 of 1/3. You're going to have 1/3 to the first power is 1/3. So this time that's backwards. 1/3 is up at 1. Again, if you want to plug in a couple more points, for example, if you want to raise it to the second power, 1/3 to the second power is 1/9. So 1/9, 2 is another point on the graph. If you want to go the opposite direction, if you want to take 1/3 and raise it to the negative first power, so 1/3 to the negative first power is the same as 3 to the first power, which would be a point at 3, negative 1. Again, we still have that asymptote at x equals 0. It's going to run along the y-axis and go through those points. If we take those concepts and we put them into graphing with transformations, then we're going to take each of those graphs and just shift them or reflect them or whatever the transformation asks you to do. In this case, this is log base 3, so I'm just going to start by putting the parent function in here, 1, 0, 3, 1, and the asymptote is x equals 0. It's going to go through those 2 points riding along the y-axis. If we take these 2 points, we're going to transform them with these shifts in the graph. This plus 2 makes it go left 2. This minus 1 makes it go down 1. So every point is going to shift 2 to the left and down 1. So this point at 1, 0, if we take it 2 to the left and down 1, that will land at negative 1, negative 1. If we take this point at 3, 1, and we go 2 to the left and 1 down, that's at 1, 0. And the asymptote that was at x equals 0 also shifts 2 units to the left. It is now at x equals negative 2. So that's the line we're going to run along and go through the 2 points we just plotted. If you look at this next one, we have log base 4. Again, we're going to put the parent function on the graph first. So 1, 0 and 4, 1 are the main points in our parent function, riding along the asymptote at x equals 0. I'm going to separate the reflect from the shift. If we rearrange this, this would be negative x plus 2. If we pull out the negative, that's negative of x minus 2. So our log base 4 function has a reflection, a shift to the right, and then a shift up. So if we're looking at each individual part of this, this negative outside of this x value is still inside the function. If it's inside the function, it's like we're waving our princess wave, or waving so that it flips over the y-axis. So it's going over here to go along in the opposite direction. Also, we have 2 shifts here. This negative 2 is going to go 2 units to the right, and this 3 goes 3 units up. So we're going to take these 2 points. If we take negative 1, 0 and go 2 to the right and 3 up, it now lands at 1, 3. And this point over here at negative 4, 1, if it goes 2 units to the right and 3 units up, it is now at positive or negative 2, positive 4. also this axis was, or the asymptote was at x equals 0, it also gets shifted 2 units to the right. So that would be at x equals 2. That's the line the log function runs along and goes through those 2 points. So the purple graph is the final graph.